A. Using the data in the table below, calculate the value of delta G degrees in kilojoules per mole of reaction for the reaction at 298 Kelvin. Visual. Delta G standard equals sigma delta G standard products minus sigma delta G standard reactants equals minus 1320.30 plus open parenthesis 2 times minus 228.59 close parenthesis minus 1795.70 kilojoules moles minus 1 equals 18.22 kilojoules moles minus 1. 1 point is earned for the mole factor for water. 1 point is earned for answer. Units are optional. B. Given that the value of delta H degrees for the reaction at 298 Kelvin is plus 105 kilojoules per mole of reaction, calculate the value of delta S degrees for the reaction at 298 Kelvin. Include units with your answer. Delta G standard equals delta H standard minus T delta S standard. Delta S standard equals delta H standard minus delta G standard slash T equals 105 minus 18.22 kilojoules moles minus 1 slash 298 Kelvin equals 0.29 kilojoules K minus 1 moles minus 1 or 290 J K minus 1 moles minus 1. 1 point is earned for the correct substitution of delta G standard, delta H standard, and T. 1 point is earned for the correct answer with correct units. A sample of CaSO₄, 2H2O is placed in a cylinder with a movable piston as shown in the diagram below. The air above the solid is at 1.00 atmospheres and is initially dry. Partial pressure of H2O equals 0 atmospheres. Visual. C. Write the expression for the equilibrium constant, Kp, for the reaction. Kp equals pH2O to the power 2. 1 point is earned for the correct expression, use of partial pressure only. D. Given that the equilibrium constant, Kp, is 6.4 times 10 to the power negative 4 at 298 Kelvin, determine the partial pressure, in atm, of water vapor in the cylinder at equilibrium at 298 Kelvin. Kp equals pH2O to the power 2 gives 6.4 by 10 to the power negative 4. pH2O equals SQRT, 6.4 by 10 to the power negative 4, equals 0.025 atmospheres. 1 point is earned for the correct partial pressure. Units are not required. A. If the volume of the system is reduced to 1/2 of its original volume and the system is allowed to re-establish equilibrium at 298 Kelvin, what will be the pressure, in atm, of the water vapor at the new volume? Justify your answer. The pH2O at equilibrium at the new volume will be 0.025 atmospheres. Equilibrium vapor pressure is dependent on Kp, which in turn is a function of temperature, not volume. Because the temperature is still 298 Kelvin, the vapor pressure of H2O remains 0.025 atmospheres in the new volume. 1 point is earned for the correct answer with justification. In the laboratory, the hydrate CaSO₄, 2H2O can be heated in a crucible to completely drive off the water of hydration to form the anhydrous salt, CaSO₄. F. A 2.49 gram sample of pure CaSO₄, 2H2O is heated several times until the mass is constant. Calculate the mass, in grams, of the solid that remains after the dehydration reaction is complete. Molar mass of CaSO₄, 2H2O equals 172.172 grams moles minus 1. Molar mass of CaSO₄ equals 136.14 grams moles minus 1. 2.49 grams CaSO₄, 2H2O times 136.14 grams CaSO₄ slash 172.172 grams CaSO₄, 2H2O equals 1.97 grams CaSO₄. 1 point is earned for the rounded, correct molar masses. 1 point is earned for an answer consistent with the molar masses.